All right, honors chemistry people, we are going to do some more moles today. So you're going to want a calculator. So make sure you've got a calculator. You're going to want a periodic table nearby, and you're probably going to want to make sure that you know these conversions. Okay, so when we left off, we said that if I had a molecule instead of just an element, I had to add all the atoms together to find the molar mass. And so we did that with water. So water, we have H2O, which means that we have 2 times the hydrogen, right? We've got that 2 hydrogens, and we have 1 times the oxygen. So we get a molar mass of 18.02 atomic mass units. So if we have that in moles, that means we would have 18.02 grams for 1 mole of water. Okay, so let's do some more here. How many grams of water are needed to have 0.75 moles? So I'm going to start with the number that's given me, 0.75 moles of water. And I want my moles of water to cancel, so I'm going to put moles on the bottom here. So in 1 mole of water, according to this up here, that gives me 18.02 grams of water. Okay, so all I have to do now, my moles of water cancel out. I have grams of water for my unit. So I'm going to take 0.75 moles, or 0.75 multiplied by 18.02. Notice I only have 2 sig figs here. So when I do that, I will get 14 grams of water. Okay, so do you think I can go the other way? So if I start with grams, can I tell you how many moles of water I have? I sure can. So I'm going to start with the 35.6 grams of water. And in this question, it asks me how many moles I want. So I'm going to use the same relationship, only I'm going to flip it this time. So instead of putting moles on the bottom, I'm going to put grams on the bottom, and I'm going to put moles on the top because I want my grams of water here to cancel out. So I have 18.02 grams of water in 1 mole of water. Okay, now I have grams of water divided by grams of water, so that unit cancels out, and I'm left with moles of water. So I'm going to take 35.6, and I'm going to divide it by 18.02, and that will give me my moles of water. Now notice that I have 3 sig figs here, and I have 4 sig figs here. So when I'm all said and done, I'm going to report 3 sig figs. So this will give me 1.98 moles of water, because that's the unit I have left, moles of water. So I have 1.98 moles. Okay, now here I have kilograms. Notice my relationship that I have up here is in grams. So the first thing I'm going to have to do is I'm going to have to convert my 4.5 times 10 to the 5th kilograms into grams. So 4.5 times 10 to the 5th kilograms of water. I should put water here. In 1 kilogram of water, I have 1,000 grams of water. Okay, so my kilograms of water cancel out. I now have grams of water. I don't want grams, I want moles. So I'm going to put grams on the bottom in my molar mass and moles of my top. So we figured out that we have 18.02 grams of water in 1 mole of water. Okay, so that's exactly what I'm asking for. I'm asking for moles of water, and that's what I have for my unit. My grams of water cancel out, so I'm good to go. So I'm going to take 4.5 times 10 to the 5th. I'm going to multiply it by 1,000, and I'm going to divide by 18.02. Now notice this 4.5 only gives me 2 sig figs. This conversion here in the middle is a definition, so it gives me full sig figs or infinite sig figs. And this one gives me 4. So I can really only report 2. So when I report that, that will give me 2.5 times 10 to the 7th moles of water. Okay, how are you doing so far? Okay, let's do one more. How many molecules are present in 4.5 times 10 to the 5th kilograms of water? Now, same thing applies, only I don't want to stop at moles now. I want to take it one step more. I want to do moles to molecules. And in order to do moles to molecules, I'm going to have to use Avogadro's number. So we're going to have to add yet another step here. So I'm going to do this in another color so it gets a little less busy. So here we go. 4.5 times 10 to the 5th kilogram of water. The first thing I need to do is get my kilograms to grams. So 1 kilogram, because I want my kilograms to cancel, of water will give me 1,000 grams of water. Okay, so my kilograms of water cancel out. Now I'm into grams, but I don't want grams, I want molecules. So I have to get my molar mass of water to get into moles. And then for moles, I can get into molecules. Okay, so I want my grams to cancel. So I'm going to put my 18.02 grams of water will give me 1 mole of water. So my grams of water cancel out. I now have moles, but I don't want moles, I want molecules. So in 1 mole of water, I have 6.022 times 10 to the 23 molecules of water. Okay, so my moles of water cancel. I now have molecules for my unit, which is what I want. So mathematically, this is what we're going to do. We're going to take 4.5 times 10 to the 5th. We're going to multiply it by 1,000. We're going to divide by 18.02. Then we're going to multiply by 6.022 times 10 to the 23. Now, once again, I only have 2 significant figures that I can report. So when I do that, I am going to get this. I will get 1.5 times 10 to the 31st molecules of water. That one didn't really show up. Let's see if I can make that more clear. No, still looks like 30. Okay, so little side note here. Whenever, oh my gosh, my computer just doesn't want to think very quickly today. Whenever I use mole in my dimensional analysis conversion factor, I always put the number 1 by it because we are always dealing with things in 1 mole increments, okay? Whenever I use grams in my dimensional analysis as a conversion factor, I'm always going to need to put the atomic mass, if it's an element, or the molar mass, if it is a molecule. Okay, my phone is going. It doesn't. Okay, so whenever I use the term atoms or molecules, I'm always going to need to use Avogadro's number. So 6.022 times 10 to the 23. I'm always going to need to use that in front of it. Okay, so we're going to do a few more today. we're going to use the periodic table here. So how many grams are there in 0.156 moles of cobalt? So I'm going to start with the number that I'm given. I have 0.156 moles of cobalt. I want to get out of moles, so I'm going to need moles on the bottom, and I want grams of cobalt. The thing is, I don't have the molar mass or the atomic mass of cobalt memorized. So I'm going to have to look at the periodic table. So let's look at the periodic table really quick. So when I look at the periodic table and I look and find cobalt, let's highlight cobalt. Cobalt has a mass of 58.93 grams per mole. Okay, so we're going to use 58.93. So let's go back here. So 58.93 grams of cobalt will give me 1 mole of cobalt. So notice for my units, my moles of cobalt cancel out and I'm left with grams of cobalt, which is exactly what I want. So mathematically speaking, I'm going to take 0.156 and I'm going to multiply it by 58.93. Notice I have 3 sig figs here, so I can report 3 digits. So let's take some time to do this. 0.156, and we'll multiply it by 58.93. This will give me, with 3 sig figs, 9.19 grams of cobalt. Okay, let's do some more. Put my calculator over here. Right. How many moles would there be in 14.75 grams of aluminum? So I'm going to start once again with the number that's given me, 14.75 grams of aluminum. Now, I don't want grams, I want moles. That means I want grams to go on the bottom so that I can cancel out grams of aluminum. And I'm going to put 1 mole of aluminum on top. Once again, I don't have the molecular mass for aluminum memorized. So I'm going to go and I'm going to check the periodic table. Okay, so let's look for aluminum. Aluminum's right here. I've got 26.98 grams in 1 mole of aluminum. Okay, so 26.98 is what I'm going to put on here. So 26.98 grams of aluminum. Notice my grams of aluminum cancel. I'm left with moles, which is what I want, right? That's asking for moles. So I'm going to take 14.75 and I'm going to divide by 26.98. Now notice I have 4 sig figs here and 4 sig figs here. So I can report 4 sig figs. So when I do the math here, I will get 0.5467 moles of aluminum. Okay. Notice that I box my answers at the end so that it's easy to tell what my answer is. It might help you understand what's going on a little bit better. Okay, let's do some more. How many atoms of aluminum are in that sample above? So if I take that same 14.75 grams, I'm going to have to get it into moles to figure out atoms. And then once I have moles, like I did in the previous problem, then I'm going to use Avogadro's number to get it to atoms. So I'm going to string this all together just so that we don't have any rounding issues. And it looks like I didn't give myself very much room when I printed up this book. So we're still going to use the 26.98 grams of aluminum for 1 mole of aluminum. Now, we're good. I mean, this is where we need to start, but we're not done because we're asking for atoms. So now we're going to have to use Avogadro's number. So in 1 mole of aluminum, I have 6.022 times 10 to the 23 atoms of aluminum. So essentially what I'm going to do is it's the same problem that we had on top, but now I'm multiplying by Avogadro's number. Same thing, I've got 4 sig figs in each of these conversions, so I'm going to be able to report 4 digits. So when I do this, I will get 3.292 times 10 to the 23rd atoms of aluminum. Okay, my dog wants to go, so I'm going to go and open the door. Want to go out? Huh? No? All right. I think she wants to know what I'm doing. All right. She is smelling the door. You want to go? Come on. All right. Okay. Next thing. How many grams are there in 0.25 moles of ammonia? I'm going to erase this just a little bit so that we can see where that is. Now, the thing is, ammonia is a molecule. It's not just an element. So we're going to have to get the molecular mass. So the thing I want to do is when we have ammonia, we've got 1 nitrogen and we've got 3 hydrogens. So we're going to have to multiply our number for hydrogen by 3, whatever we end up finding for our molecular mass for hydrogen. Come on, erase. Let's make that 3 better. Okay, so when we do that, let's look at hydrogen and let's look at nitrogen. So when we look at hydrogen, hydrogen gives us 1.01 and nitrogen is 14.01. Okay, so we can use 1.01 for the hydrogen and 14.01 for the nitrogen. Okay, so let's do that. So nitrogen is 14.01 and hydrogen is 3 times 1.01. Okay, so when we add 14.01 plus 3 times 1.01, which ends up being 3.01, or 3.03, sorry, 3.03 plus 14.01 will give us a mass of 17.04 grams per mole for ammonia. Okay, so we're going to use that conversion. We're going to start with the number that's given to me in this problem, 0.25 moles of ammonia. I want my moles to cancel, so I'm going to put my moles of this conversion factor that I just figured out on the bottom. So in 1 mole of ammonia, I have 17.04 grams of ammonia. Okay, so when I take 0.25, which only gives me 2 sig figs, times 17.04, it will round to 4.3 grams of ammonia. Okay, so next thing, we've got sulfuric acid. So I've got how many moles are in 2.5 grams of sulfuric acid. So the first thing we've got to do is we've got to find the molar mass of sulfuric acid. So notice here, we've got 2 hydrogens, we've got 1 sulfur, and we've got 4 oxygen. So we already looked up hydrogen. Hydrogen, we've got 2 of them, 2 times 1.01 for the hydrogens. Sulfur, let's look up sulfur and let's look up oxygen really quick. So when we look up sulfur, okay, sulfur's right here. It is 32.066. So we call that 32.07. And nitrogen or oxygen right next door is 15.999. So that's going to round to 16. So 32.07 and 16.00 is what we are going to use. So the hydrogen is 2 times 1.01. Sulfur will be 32.07. And the oxygen, we've got 4 of them, right? So we're going to have to multiply that by 4. 4 times 16. So we're going to add all of those up. So 2 times 1.01 plus 32.07 plus 4 times 16. Now remember your order of operations here. Make sure that you're multiplying where you need to multiply and adding where you need to add, okay? So when you get the molar mass of sulfuric acid, I'll give you a minute, you should get, why is this taking so long? You should get 98.0, good heavens, 0.08 grams of sulfuric acid per mole. Okay, so we're going to use that conversion in this problem. So let's start another color here. So if I have 2.50 grams of sulfuric acid, I want my grams to cancel. So I'm going to put my grams of this conversion factor on the bottom. So 98.08 grams of sulfuric acid will give me 1 mole of sulfuric acid. And that's what I'm going to end up doing. Notice I have 3 sig figs here and I have 4 sig figs here. So with just 3 sig figs, this will give me 2.55 times 10 to the negative 2 moles of sulfuric acid. Okay, just a quick note over here. Please note, let's change the color. Please notice how I always try to show units in my setups. You need to do the same. So units are always shown, right? We always show units. Remember, the unit that you want to get out of always needs to be on the opposite side. So if you want to get out of that unit, it needs to always be on the opposite side of the next step. So for example, if I want to get it out of grams of aluminum, the grams of aluminum needs to be on the opposite side of that next step. Okay? Unit analysis is something that we do all the time in chemistry. Okay, so next thing, how many molecules are in that 2.5 grams of sulfuric acid? So we're going to do the same thing, but now we are going to go to molecules. So we are going to have to use Avogadro's number. So same problem, we're going to string it all together, but we're going to add an extra step. So I'm going to start with my grams of sulfuric acid. I don't want grams. I want them to cancel. So I'm going to put grams on the bottom of the molar mass. And that will allow me to get into moles of sulfuric acid. So my grams cancel. I now have moles, but I don't want moles. I want molecules. So in order to get from moles to molecules, I use Avogadro's number. So 1 mole of sulfuric acid will give me 6.022 times 10 to the 23 molecules of sulfuric acid. Okay, so my moles cancel, and now I have molecules, which is exactly what I want. So once again, I have 3 sig figs. So if I look at this and round to 3 sig figs, this will give me 1.53 times 10 to the 22 molecules of sulfuric acid. Okay, so let's do another one. How many moles are there in 72.9 grams of hydrochloric acid? HCl is hydrochloric acid. So the very first thing we've got to do is we have got to, I'm trying to figure out what we've got here. We've got to figure out our molar mass of hydrochloric acid. So we've got 1 hydrogen and we've got 1 chlorine. We've already looked up hydrogen a couple of times. Hydrogen is 1.01 grams, but we have not looked up chlorine. So let's look up chlorine. So if I look at chlorine, it's right here. We have 35.45. So we're going to use 35.45 for our chlorine. So let's go back. So the hydrogen was 1.01. The chlorine is 35.45. We're going to add that up together to make hydrochloric acid. So we will get 36.46 grams per mole of hydrochloric acid. So we are going to use that conversion factor. Let's start off with the number that's given us. We are given 72.9 grams of hydrochloric acid. We want our grams to cancel. So in the next step, it needs to be in the opposite side. Hopefully you said opposite. So we need to put the grams on the bottom. So we're going to put the 36.46 grams of hydrochloric acid on the bottom. And we're going to put our 1 mole of hydrochloric acid on top. Our grams cancel and we are given moles. Okay, so when we do this, 72.9 divided by 36.46, I'm thinking we're going to have 2, almost 2. I have 3 sig figs. So my calculator gives me 1.999. So that 9 tells me to round up, which essentially gives me 2.00 moles of hydrochloric acid. Okay. How many moles are there in 79.85 grams of iron 3 oxide? This is known as rust to you guys. So the very first thing we've got to do is we've got to find iron, and we've got to find, well, we've already found oxygen, right? Oxygen is 16 grams per mole, and we've got 3 oxygens. Let's find iron first. Let's look on our periodic table. So if I look at iron to the 100th, I will have 55.85. 55.85 for my iron. And oxygen, once again, is 16.00. So we're going to use that. Okay. So iron, I've got 2 of them, and it's 55.85. And oxygen, I have 3 of them, and it's 16.0. So we're going to add that up all together. So 55.85 times 2 plus 16 times 3 gives me a mass of 159.70 grams per mole. Okay. Now your calculator probably spit out 159.7. Remember, I want molecular masses to go to the hundredth, so that 0 is significant. Okay, so I want to keep it that way. So we have 79.85 grams of iron 3 oxide, otherwise known as rust. We're going to want the grams to cancel. So I'm going to put my grams of my conversion, my molar conversion factor that I just figured out, I'm going to put that on the bottom. So 159.7 grams of iron 3 oxide is in 1 mole of iron 3 oxide. Okay, my grams of iron 3 oxide cancel out. I have moles. So I'm going to take 79.85 and I'm going to divide it by 159.70. And this will give me, I have 4 sig figs here. I have 5 sig figs here. So I'm going to report 4 sig figs. This gives me 0.05000. Remember, this 0 at the front is just a placeholder. So this does give me 4 digits that are significant. Okay. And then we need to label this with a unit. This is moles of iron 3 oxide. Okay. All right. Wow. It didn't like me. I think that's enough for today. We're going to do some more practice tomorrow. Okay. And we will consider this good. And happy mole converting. We'll talk to you later. Bye.